All right, let's talk about a movie that is just as much a scientific puzzle as it is a cinematic masterpiece. Christopher Nolan's Interstellar. Today we're going to break down that absolutely mind-bending ending, try to figure out where the real physics stops and the movie magic takes over, and really dig into the meaning at the heart of it all.
This quote right here from Dr. Brand, it's just the perfect way to kick things off. It pretty much sums up the entire movie, doesn't it? It's this incredible story that tries to connect the cold, hard laws of physics with, well, the most powerful and maybe unmeasurable human emotion of all.
Can you believe it's been over 10 years since this movie came out in 2014? And what's crazy is Interstellar is just as powerful today as it was then. I mean, the ending, the science, people are still debating it all over the internet. And that recent IMAX re-release, it was a huge box office smash. It just goes to show our fascination with this journey is not faded one bit.
So, just in case you need a quick refresher, the basic setup is, well, it's pretty haunting. We're in the near future, and Earth is dying. A massive environmental disaster is making the planet uninhabitable. Our hero, Cooper, he's a former NASA pilot who's now a farmer, and he gets pulled into this last-ditch, desperate mission to travel through a wormhole and find a new planet for humanity. The catch? He has to leave his kids behind, with absolutely no guarantee he'll ever see them again.
Okay, Section 1. Inside the black hole, demystifying the Tesseract. All right, let's dive right into the part of the movie that leaves everyone talking, the big climax inside the black hole. This is where the film takes its biggest, wildest leap, so we're going to break down exactly what is going on when Cooper flies his ship straight into Gargantua.
So here's how it goes down. First, Cooper makes this huge sacrifice, right? He detaches his ship to save Brand, slingshotting her away from Gargantua's pull so the mission can continue. He and his AI buddy Tars then fall into the black hole. But, and this is the key part, instead of being crushed into nothing, he ends up in this bizarre five-dimensional space called the Tesseract. From inside this thing, he can look into his daughter Murph's bedroom at any point in her past, and that's when he realizes he can use gravity to communicate with her, to send her the quantum data that Tars collected, the exact data that humanity needs to survive.
So what is this Tesseract exactly? Well, according to the movie, it's a structure built by these mysterious five-dimensional beings. They've basically created a space that translates their higher-dimensional reality into something Cooper, a three-dimensional human, can actually understand. It's wild. Time itself becomes a physical dimension. Imagine it laid out like this infinite library, and he can just move through different moments in Murph's life like he's pulling books off a shelf.
But that just leads to the biggest question of all, right? Who built this impossible thing? Throughout the entire movie, the characters keep talking about they. They put the wormhole there. They are helping us. So who are they? And here it is, the big twist, the core of the whole paradox. They aren't aliens, not at all. They are us, a super-evolved future version of humanity that figured out how to exist in 5 dimensions and manipulate time itself. They're the ones who built the Tesseract. They reached back into their own past to give Cooper the tools he needed to save humanity, which of course allows them to exist in the first place.
Section 2. Science. Fact versus fiction. I mean, it's a classic time travel paradox, and it is just brilliantly done. But it definitely makes you wonder, right? How much of the science in this movie is actually real? So let's try to separate the real established physics from, the Hollywood magic.
Okay, so let's get into the Miller's Planet debate. This is a big one. The water planet where 1 hour on the surface is 7 years back on Earth. Now, a lot of people criticize this, saying there's no way a planet could have a stable orbit that close to a black hole to get that kind of insane time dilation. But here's the thing. The movie's science advisor was Kip Thorne, an actual Nobel Prize-winning physicist, and he did the math. He calculated that if the black hole was spinning incredibly fast, like close to the speed of light, it could theoretically support an orbit like that. So one of the most sci-fi moments in the film is actually plausible.
And, speaking of Kip Thorne, his biggest contribution might just be the black hole itself, Gargantua. He literally gave the visual effects team the real-world equations from Einstein's general relativity. They then had to build a brand new software renderer just to handle the math. Get this, some individual frames took over 100 hours to render. All that work created what was, at the time, the most scientifically accurate picture of a black hole ever seen in a movie.
And this is where it gets absolutely incredible. Years later, in 2019, the Event Horizon Telescope project captured the first ever real image of a black hole. And when you put them side by side, the resemblance to what Nolan and Kip Thorne created is just astonishing. It's almost identical, right down to that glowing ring of superheated gas and dust around the edge. So, when you look at the whole picture, most physicists will tell you the movie gets a shocking amount of stuff right. That core idea of gravitational time dilation, that is 100% real. The way they showed the wormhole as a sphere instead of a long tunnel, that's also considered way more plausible. And, like we just saw, their black hole visualization was absolutely groundbreaking.
But of course, it's still a movie, right? They had to take some creative liberties. The whole idea of a time-traveling library inside a black hole, that's pure science fiction. The truth is, we have no idea what's in there. And the concept of solving gravity, figuring out how to control it to lift giant space stations off Earth, that's a great plot point, but it's not based on any real-world science we have today. Oh, and yeah, those weird, solid floating ice clouds on man's planet, pretty sure that's not a thing either.
Section 3, Love, Gravity, and Paradoxes, the philosophical core. But, what's maybe even more interesting than what's real or fake is how the movie uses all these big sci-fi ideas to get at something deeper, something more philosophical about who we are.
So, to really understand that ending, you have to wrap your head around a classic sci-fi idea called a causal loop. You might have also heard it called a bootstrap paradox. Basically, it's a situation where a future event causes a past event, which in turn causes that future event to happen. It's a circle with no real beginning or end.
And Interstellar's entire plot is built on one of these loops. Remember the ghost in Murph's bedroom pushing books off the shelf? That was Cooper the whole time, communicating from the future inside the Tesseract. He's the one who sends himself the coordinates to NASA, which kicks off the very mission that allows him to be there in the future to send the coordinates. It's a total mind-bender, and it brings up those classic Christopher Nolan questions about fate versus free will. Like, was Cooper ever really making his own choices, or was he just an actor playing a role in a story that had already been written?
And this brings us to the movie's boldest and maybe most beautiful claim. That whole paradox, it's not just a clever plot trick. It's how the movie delivers its core message. The force that allows Cooper to communicate across time and space, the thing that anchors him to that specific person in that specific room, is his love for Murph. The film is basically arguing that love isn't just a feeling. It's a physical, maybe even quantifiable force. One that can transcend dimensions, just like gravity.
Section 4. Our real interstellar future, from fiction to reality. So this incredible vision of our future in the stars brings up one last fascinating question. How does the science fiction of Interstellar stack up against the real-world challenges of actually getting out there? Interstellar is all about black holes and relativity, right? But in reality, the biggest hurdles for long-term space travel are much more, human. I'm talking about biology. We know from astronauts on the ISS that they face huge challenges. Muscle and bone just waste away in microgravity. There's a much higher risk of cancer from all the space radiation. And then there's the incredible psychological stress of being isolated in a tiny box for years on end.
And that's just staying healthy. Actually, getting to another star is a whole other problem. We've got some promising technologies, sure. Ion drives are super efficient, but they have really low thrust. It would take forever to get anywhere. Nuclear thermal rockets have a lot more power, but then you're dealing with, a nuclear reactor and all the safety issues that come with it. And then you get to the really theoretical stuff like warp drives. The idea is to literally bend space-time around a ship. But to do that, you need something called exotic matter, which is basically material with negative mass. It's a cool idea, but we don't even know if something like that can exist.
And, just like in the movie, the challenges aren't just about the tech. Once we start seriously thinking about becoming an interstellar species, we run into the exact same massive ethical questions the characters did. Who owns what we find out there? What do we do if we find life? How do you govern a society that's light years away from home? These are huge questions we don't have answers for yet.
And that brings us all the way back around, right to the heart of the film's message. Interstellar says over and over that our destiny isn't on Earth, that we're meant to leave it. But the entire thing that saves humanity is the unbreakable bond between a father and his daughter. So I'll just leave you with this final thought to chew on. Is the movie really about our grand destiny to conquer the stars? Or is it telling us that the connections we have with each other are the most powerful forces in the universe, and the only things that will ever truly save us, no matter where we end up?